Welcome, everybody. We are going to be working on Unit 12 tonight, and we're going to start by talking about some concepts. And since I have the anticipation that we're going to be getting a bunch of ads on our screen, I'm going to use the Brave browser to do some of this stuff here. We're going to talk about this concept called stored procedures. We're also going to talk about uh, functions that are custom created instead of using previously built ones, how that's a benefit to our code because the two concepts are really very similar, but they operate a little bit differently, and why they're valuable. And I have some information that I added here today because when you originally looked at this, there was just a link to this material. So I thought I'd post some of the information here. I also posted some information about stored functions, right? So just a quick overview, and then the concept of delimiters and how we use those in our code. All right, I'm going to travel us now over to the MySQL tutorial site here in the Brave browser once again, just to minimize all the pop-ups and the ads that I normally get inside of Chrome. And I take you to this page here, and I'm going to kind of do a quick overview of all the material, and then we'll dig into the specifics here. But basically, we're going to look at what a stored procedure is and how it works, why we use them, and what's good about them and what's challenging about them. We'll talk about the default delimiter, how to create them, how to remove them, and then some of these other topics we're just going to very quickly brush against very quickly, right? I don't want to spend a lot of time on that because we're looking at the higher level concept. There's also the ability when we get into procedures, because we're really writing, and I want you to think about this, we're not just writing SQL queries at this point, although queries are still part of it. We're writing a bit of pre-compiled code. And what that means is it's pre-created just the same way that in Unit 11, we pre-created a view and we don't have to write that code over and over again. A procedure is similar, but it also gives us the ability to add programmatic commands to the SQL code. And this is really important. So that includes things like conditional statements, like an if statement, right? Like if this is true, do that. If it's not, do that. That type of thing, which is very helpful, right? It makes it more like real programming. And we've looked at that briefly before, but very briefly. You can also throw in programming loops, right? So those of you that have had a programming language previously, and I'm hoping all of you have, but if you haven't, right, this might be a new concept to you, the ability to take a piece of code and just basically reiterate or iterate or run it over and over again. And you'll notice that we have a few different types of loops and how we get in loops and out of loops, and that's all covered there. Once again, we're not going to do that here today, but I just want you to be aware that when we start doing stored procedures, we have that ability to do conditional statements, basically selection, or decisions, if you want to call them that, or looping, which is to repeat blocks of code. We can also throw in error handling, another thing that kind of comes in from traditional programming. Like, so we'll do a tad little bit of this, by the way, but not a lot. We'll use the signal command basically, so that if somebody does a piece of code and let's say the input to the code isn't right, you can throw a message on the screen, kind of like when we're working inside of MySQL Workbench here. You have a little console here at the bottom and you run a command and you see like, good, the green check mark, or bad. And then you get these error codes. And what I'm going to show you is that you can generate those error codes yourself. So if somebody's using one of your procedures and it doesn't work, you can send a message to the screen that might help them. We'll also look at this concept of cursors, right? Where basically you're processing row by row. And this is, once again, we're just going to touch upon this very super briefly. And then we'll look at functions, which is the other kind of major topic. Very, very similar, basically, to stored procedures. So let's go back up to the top here and dig into the stored procedures and learn what they actually are. All right, so I'm going to open that up in a new tab here. And basically, when you work with a stored procedure, think about this. Like we created a view and we learned that a view is like a pre-configured query and then we can run it. And the stored procedure is very similar. So they're giving us an example here of a basic query and a table that we're running the query against, right? So we are pulling this information from that query. All right, so when we run a regular query, we get a result set, right? And then if you wanted to save this query on the database server for later execution, one way is to use a stored procedure. So this is one of the advantages of it. So we don't have to recreate that query over and over again. So once again, similar to the view concept. All right. When we create a stored procedure, right, I want you to notice that there's a syntax that goes with it. So basically, we will first set up what we call a delimiter. All right, so the delimiter basically does this. Instead of looking for a semicolon, where's my semicolon here? Right here, right? Which terminates a SQL statement. I'm telling the SQL engine basically, hey, for right now, don't worry about those semicolons. Instead, look for the $sign to look for the ending of the code, right? And you'll notice that'll come right here. So I will create a procedure, right? I will give it a name, right? And then what is the procedure? Well, here's the beginning, here's the end, and then here's the query inside of it. Now, this is a pretty basic query, but it could be highly complicated, and it could contain calls, mind you, to other stored procedures or views or functions or whatever. It could have math in it, whatever. It could have some very complicated stuff in there. When we're finished defining it, so the begin and the end, along with a delimiter, are telling us what's inside that stored procedure. In this case, a simple query. After we run all this, we then run this command also, which includes basically the flip back to the original semicolon as the delimiter for our code. So then we're saying, all right, we did this procedure, but now you can put the delimiter back to the semicolon. So basically the delimiter command is really overriding the semicolon. All right. Now here's some of the depth of this. It says, by definition, a stored procedure is a set of declarative SQL statements stored within the MySQL server. So after we create it, it gets embedded into the product. And if you guys look at like our database structure here, you'll notice like just the same way we have an area for views, we also have an area for stored procedures and functions. So it'll get stored here and there'll be a little tree that forms with those items. So here they're kind of using an example that we created one called Get Customers, and after saving it, you can just simply call it to run. So I don't have to rewrite all that code. You literally use the call command and it calls that procedure to run, right? The statement returns the same result as the query that's inside of there, right? And it does a few different things here. And I detailed this in the notes in the class too. It says first, it finds the stored procedure by name inside of the database. Then it will compile the code of the stored procedure. It will store the compiled code in memory, and then it will execute the procedure. Now, I know that seems kind of weird. So in other words, if you think about what it's saying, is it doesn't really compile the code until you call it to run. But once you run it and it's in memory, right? And think about this, most databases when they're running, that you usually don't shut them down. It'll be stored in memory. So every time you want to run that procedure, it's already in memory. It will execute really, really fast. And that's one of the advantages of this. So it's complex code and it's already in memory and it's something you do all the time. This is where the advantage of this is. All right, so it says if you invoke the stored procedure again within the same session, it will execute from the cache without need for recompilation. So makes it quick. Stored procedures like functions or methods in programming allow you to send parameters or information to the procedure so it can basically receive information to process and also send back results, right? Because we can define it kind of like a little bit more like regular programming code, we can have conditional statements, as we talked about before, if statements, basically to check certain things. And we can also create loops, right? Um, it has the capability of calling other stored procedures or stored functions. And basically what it does is allows us to write more powerful code that's reusable and works quickly, right? Because it has this capability of getting stored in memory after it's compiled, it will end up reducing network traffic, right? So we don't have to send all this code and receive all this code. It's already in the memory in the database. We just trigger it to run. It makes the logic, or what they call the business logic, or like programming logic, really, in the database centralized, right? So like you can think of something in a stored procedure as like a higher level command that really does a bunch of nitty gritty work in the background that you really don't care about, but it works, right? And once you've created it, it's kind of like using a function in a programming language. Well, when I call it, it just does all these tasks. I don't have to worry about how those happen. They just work, right? And then because of that, it also makes the database more secure, right? People aren't going to go in there and mess with the queries. You're just calling this higher level procedure, which does a bunch of work for you. And often when you write higher level applications, they're triggering stored procedures in a database and not really necessarily writing the higher level code. It does have a few disadvantages, right? So like one would be resource usage, right? Because if you have a bunch of stored procedures and they're all loaded into memory, okay, well, that's chewing away at your memory, which is going to slow down the system. If you have ample amounts of memory and a powerful CPU, not a problem. But it can have an impact on performance if you have too many of them loaded in memory, or if what you're loading is huge, right? It also makes troubleshooting hard. So if you're like the database designer or admin and you're trying to fix a problem, well, you're going to have to re-engineer that stored procedure probably to fix it, right? Which means compiling it again and all of that. And this is notable, right? And it's like indicated here. If you worked on a higher level database system, so if you worked on Microsoft SQL Server or Oracle's full-blown Oracle database, you could actually debug the stored procedure without rebuilding it. MySQL lacks that feature because it's not what we call an enterprise level database, right? It's a slightly lighter weight. And, maintaining this stuff is a little bit more tricky because if you're not picking up on the fact, like if you're already a good computer programmer, maintaining stored procedures is easier because you understand programming, right? Now, if some of you are taking this class and you've not had the Python class or not had Java or JavaScript or, some other programming language, these concepts will be really foreign to you, right? And this happens, right? So we have people that come in, take this as their first class, and then learn Python later, right? And then if you're coming in knowing Python already or any other programming languages, the concept, for writing this type of code is a little bit more helpful. All right. Let's talk about changing the default delimiter. And this is a pretty easy concept, right? But whenever we put in this statement, we put in a space after it, and then we tell it what the new delimiter is. So if I don't want to use semicolons at the end of my SQL statements, I can just put in the delimiter command and then just use double slashes at the end instead. That's what it means, right? When we write more complicated procedures, like here's one that's a little bit more complicated, right? We are obliged to change the delimiter because otherwise, anytime we would hit a semicolon in this code, it would kick out and stop, right? That's not acceptable, right? This allows us to keep those in place, change the delimiter to something else, build our whole procedure with the begin and the end and all the code that goes into it. And then when we're done, we use the declared delimiter to say, okay, we're done now. And then we switch it back to a semicolon so we can write regular queries again, right? So we're going to do that process. All right. So that's all I'm going to say on that topic. Now I'd like to move on to some of these other things here, and the fact that we can work with variables and different parameters and stuff. Once again, this is a super fast look because I do want to get to coding this stuff, and I don't want to chew up all the time with lecture. But if you want to remove a stored procedure, you do this, right? You drop it and indicate its name. All right. Sometimes you're not even sure if it's there, so you might add, and that's what the square brackets are about. If it exists, drop it, right? Now, if I ran the command without if it exists and it wasn't there, I would get an error, right? So that's kind of the thinking on there. That's usually one of those things you can just check it and see if it's there and then remove it. But if you're not sure because it's a big complicated database, you don't want to look, you add if exists to it. So it is possible if you create a procedure to also remove it. And that's about all I'm going to say on this topic. So I'm just going to move on. The fact that we can use variables. Okay, so now once again, this is more like regular programming now, right? Because we're not stuck to using things that we've either created, like a view, or that's already in a table, like a column that's in a table, and then giving it an alias. Sometimes we need, in order to make an action in our stored procedure, and you can think of a stored procedure as basically a program, right, as opposed to just a query. Sometimes it's helpful to have a variable that can temporarily store information. So once again, if you've had programming, you get this concept. If you haven't, a variable is basically a named storage space in memory that holds a certain type of information. So I have to give it a name, right? And I have to give it a data type and its size, and optionally a default value. Now, when we are building these stored procedures, at least the ones that we're going to do, we're not necessarily going to declare a variable off the bat, but we do want our stored procedures to basically be allowed to accept incoming information as part of their structure, right? And we can indicate that, like when we name the stored procedure, we're going to follow it with a set of parentheses, and then we're going to indicate whether the information is coming in or leaving, or both. Maybe it's coming in and then leaving also, implying that it'll change when it's inside the procedure. So the in parameters, that's the default mode, by the way, as it says here, will indicate what we're sending in. It will be named internal to the stored procedure. It will have no effect on anything outside of it, and what data type it is. The output is the same. This means that we're sending it out when it's done. Also what data type it is. And then the in and out, once again, is the combo, where it's coming in and it's going out. And that implies most likely it's going to change when it's inside there, right? And we'll see that. But I just want to give you a look at a basic one here, because what's most common, like if you were writing like computer code like this, and you were, think about Python where you're creating a function. And if you guys remember in Python, how do you create a function? You define it, you use def, or if you're in Java, you use the keyword function, right? That kind of thing. And then you give it a name and you follow it with a set of parentheses. But in SQL, for whatever reason, the convention is you split the parentheses like this. You indicate whether this is an incoming piece of information or outgoing or both, right? You give it a name, and then you give it a data type like you do when you're creating a table. Then you go ahead and you do your begin and your end and write your query, right? But in order to run this query, it's going to require this piece of information. I want you to be mindful of the fact that whatever you name that's like an internal variable. And that, if you're not careful with that, you can kind of pollute your other content. Like if I so like country, well, that's the name of a country. And here I'm calling it country name. What I might also suggest, and some people will do this, is they'll have, like we did with a view where we use like VW underscore, you might want to even consider having some sort of a prefix or a suffix that indicates it's a parameter, so that you can tell that it's an internal parameter and not a column name from a table. You guys are feeling where I'm going with that. Once again, we'll look at how that works as we're writing our code, but I think that's a good overview of that. I'm going to skip these two topics here. I do want to talk very quickly about if statements. Case statements are similar, and we also have the capability, like we do in all programming languages. So once again, if you know programming, it helps. But an if statement checks if something is true, and if it's true, it executes a piece of code. If it's not true, nothing happens. You can also put in an if else, which is check to see if it's true and run the code. Otherwise, if it's not true, do this instead. So it's going to either or. And then you have what we call basically a nested if, which is you check one condition. If it's not true, doesn't happen. Check another condition. If it's not true, doesn't happen. And then an else would happen either way. So we have kind of like all the same concepts that we do in traditional programming. And SQL does have a case statement as well. I'm trying to scroll to it. Oh, I guess I don't even demonstrate the case. All right, they don't even demonstrate the case statement, but that's kind of like a fancy if statement. I'm sure you could look it up. All right, going back, we can also do looping. I don't think any of our code requires this. We are going to do some if statements, but this is I would call this a more advanced feature, so I'm not going to cover it here, but you can certainly read up on it. And those of you that already know programming and looping, it is possible to do these kind of things. And once again, I'm going to say that what we're really touching upon here is the fact that when we do a stored procedure, we're really writing a program as opposed to making a query, right? All right. We also have error handling that's built in, folks. And this we are going to play with a little bit. And I'm going to look at my sample code here. I'm trying to see like which things that were, I think the only command we're really going to play with is the signal command for the most part. So I'm just going to hit upon that one. So in other words, if we run usually an if statement and the condition isn't true, or like, so for example, let's say your procedure requires a person's name, but instead you're sending in a number, which is an integer. The code's going to fail. So we write an if statement to test it, and then we'll write a signal state that basically will trigger a value. And I'm trying to look for an example here where they include it. Like this. Okay, so if you run an if statement and it triggers, right, which means there's an error, it's going to whatever, it's going to basically trigger this SQL state, which is like an error code, and then the error message, and then that error message would throw up in the console because it won't work, right? And then you get the error in the console, and you can control the error that goes in the console. That's basically what we're building here. So these are really the only two pieces that we really want to throw in here at this point from this material. And I don't want to make it any deeper than that. Now, we're also going to use stored functions. We're only going to do one exercise, I think, with the stored function. And then I just want to show you how this looks a little bit different than, and really conceptually works a little bit different than a stored procedure. A stored procedure has the capability, mind you, to just run a certain action, and it can be programmatic. It also has the capability of receiving information or sending information out, or taking one piece of information, changing it, and sending it back, right? Stored procedure can do that. A function is very similar. However, right, and I want you to read what it says here. It says, typically you use stored functions to encapsulate common formulas or business rules, making them reusable across SQL statements or other stored programs. So for example, when we use the round command, that's a pre-built function. We didn't build it. It was already part of the language, but we send it a couple of parameters and it just works. And that's how functions are too. They do simpler things, usually mathematical, and they always return a result. A stored procedure does not necessarily return a result. That's kind of the difference. It says, unlike a stored procedure, you can use a stored function in SQL statements whenever you use an expression. So, so I can't take a stored procedure and necessarily put it in my regular SQL code. I can, however, write a regular SQL statement and call one of my functions. You see the difference? So that's pretty powerful. The syntax for creating it is kind of similar, right? So we have basically delimiter, the function name, the parameters we're sending in, what it returns, and it has to return something, whether it's deterministic or not. We'll talk about what that means, and then all the statements we're going to execute, right? They have an example here of like how we would do this. So I just want to get down to the example so you can see it. So here's one that we're calling create function customer level, and we're declaring a data type. This implies that it's received, right? It's going to return something, and what it returns, we don't necessarily have to name it, but we have to indicate what data type it is. So we're going to receive a decimal number of 2 decimal places, but we're going to return a piece of text, is what this is telling us. This is going to be deterministic, meaning it's going to be kind of final. We'll talk about that word again in a minute. And then it goes through like whatever logic. Now notice there's a logic here. It's kind of like a computer program where we're checking values, we're running if else and whatever. And then we're using what we call the set command to set the value that we are going to return. And at the end of the whole thing, when we're all done, we do have to have a return statement that sends back the thing that we're working with. So basically what we're doing here is we're sending in a value, looking at what that value is, and depending on that value, setting a piece of text to, you know, what kind of, I guess, customer level they are, platinum, gold, or silver, you know, that type of thing. So the calling of it is actually pretty simple. We call it like every other function, right? So I can put it right inside of a query. This is the cool part about functions and why they're so useful. So you pull the customer name, and then it does, you know, checks their credit limit, and then declares them as a certain level, right? I don't really care what the logic is behind it, right? It just works. And I can put it in a regular query. So it becomes like another function in my toolbox that I can just pull in dynamically whenever I need it. I can include them in stored procedures. I can include them in other functions. I can just put it in my regular SQL code, right? So you can see what the advantage of this is. This is a pretty useful little tool. All right. I think that covers all the main topics I wanted to talk about here. I think the only weird word is maybe that deterministic thing, but you know what? We can always look that up as we kind of move forward. This is going to cap the lecture piece for this. And you can tell I'm trying to do this as quickly as I can because I want to get to coding the exercise. So this video will, and you know what? I'm going to change my mind, right? And this is kind of weird doing a video. Let's just record the exercises straight away. Does that sound all right? Sure, why not, right? Since we're doing it live in class anyhow, and next time I do this, it'll probably be the same way. It's kind of the benefit of showing up for class. All right, so we're going to close all these tabs here. We're going to come back to MySQL Workbench. We're already logged into our database. I'm going to close all my previous query windows. I'm going to bring the console output window down a bit. And I'm going to pop back over to the core shell here and bring up the assignment. And actually, I think I have it open here somewhere. Let me just do this here. There it is. So I'm just going to pull that over to the screen here, and we're going to start reading through this and executing the tasks. Most of what we're going to do here is going to be basically a different, I'm going to teach you guys a slightly different approach to how to like proceed with this. Because I could take all the code I'm going to write today and put it in one big SQL file and then run it and whatever. However, especially with stored procedures, what I think is really, really useful is a stored procedure to sit in its own SQL file. So if I ever want to revise it in the future, I have it in one file. I don't have to like go, where did I put that SQL file with all that stuff in it? It's got its own name. And if I name it well, it'll be really easy to find and look up. So that's one thing that I'm going to do. The other thing that I do want to point out here is because we will run into issues here today if we don't tweak this, is to go and tweak your preferences. So go to your edit menu, click on preferences, go to the tab on the left here. It says SQL editor, scroll down to the bottom. And I made this mistake last time I did this, because your screen might be like this, but there's this checkbox here. We need you to uncheck that checkbox. If it is checked and you're unchecking it, after you say okay, it's going to be mandatory that you go back in and restart MySQL Workbench. You also might find, depending on how your database is running, and so this may or may not be necessary, is you might also need to go into your task manager, go to services, find MySQL here, wherever it's running, and start and stop it. That might be necessary too. I'm just telling you that in advance. So if you're changing something in the preferences and you say, okay, while MySQL Workbench is running, and possibly while your database is running, it won't change, right? Some people fix it by just rebooting. I guess that works too. But you can stop and start MySQL Workbench, and you can start and stop MySQL as well. Now, one of the reasons that happens, and be mindful of this, is because we are writing stored procedures and they're getting compiled and stored in memory when we're executing them, right? And sometimes that stuff gets locked there. We also want to overcome some of the limitations that are inherent from that little menu selection, right? Because updates, basically, it rejects updates and deletes with no restrictions. So, like if you're trying to update something or delete something, right, which we're going to try to demonstrate anyhow, it might block you, right? For us as, think of us as DBAs, like we're database administrators, we control the database. That should not be on. If somebody else is going into our database and messing with things, we would probably turn that back on, right? The last thing we want is somebody who doesn't know what's going on deleting or updating our content, right? Right. Okay. So that's kind of the why on that. But if you make that change, make sure you restart MySQL Workbench. If you're still getting the same results, also restart the server. Worst case scenario, reboot, right? Because otherwise those preferences do not get locked in until the product starts again. All right. Back to the document here, and let's kind of read the instructions and get rolling on this. It says create the stored procedure named get products below, which will work with the My Guitar Shop database. We're going to use the same database again. Create the procedure below using the final criteria. So they're going to give us the parameter list and what to name it, right? And I do want you to notice here, and I'll just do two more levels of zoom here. This is like inbound data. And I want you to notice that they're using the suffix in this case of parameter. Now, this once again is going to be only used internally, and we're using that to kind of identify it that it's an internal variable or parameter, if you will. It tells us what fields to set, and there's also some criteria there of being equal to $500. And we're also being told to change the delimiter, but we're not going to use dollar signs. We're going to use forward slashes. All right. I'm going to do a really quick pause here to answer a question. All right. Let's flip over here and start to write some of this code. And first things first, right? Let's create a new SQL file. In fact, let's create two new SQL files. All right. So I'm going to create one where I'm going to write the new procedure, right? The stored procedure. And then I'm going to create another one that I'm going to use to execute all the procedures and functions, right? So this is kind of a slightly different approach for us. So I'm going to start by taking this first SQL tab here. I'm just trying to see, what did I name it last time? I called it miscellaneous statements to run stored procedures and function SQL. Okay, that's what I called it. So I'm going to do a save as on this right off the bat. And we're going to save the script, and then I'm gonna name it unit 12, just so next time I look at this, and I'm just going to call it miscellaneous statements to run stored procs and funcs. How about that? A little abbreviated, but notice I'm being like super verbose. So when I look at it, I'm like, oh, this must be for unit 12 to run everything. Hey, makes sense. Right. So I'm going to just save that. So I'm going to use this one to steer everything. Now, I know that my guitar shop is already active, but I'm going to start with a use statement inside of here. And I'm just going to say, use my guitar shop, semicolon, and we'll run it just to make sure we're attached. And we are, and it's highlighted. Okay. And then after I create my first stored procedure, I'm going to come back here and type in a command to run it. Okay. In this other tab that I created, I am now going to build that stored procedure we were talking about, which is called get products. I'm going to begin by actually saving the file. This is a little bit different approach too. And I am going to call it, once again, unit 12. And then I'm going to call it get products. And if you want, you can name it just the way you build it, get products. And I'm also going to indicate STORPROC so that I know when I look at it, just as a file, what is this? Oh, it's the get product stored procedure. Got it. You know what I mean? I don't have to like open it to see what's inside there. Be verbose with your file names because it helps you as you're going down the road. After I type in my code, of course, I will save it. Right? We were told to create a new procedure, and there's a command for that, but we were also told to set a delimiter. And so I'm going to do that. And I'm going to zoom in here so you can see it a little better. And when you put in this command, and I was watching this last time, and already I spelled it wrong. I did a delimiter, not a delimiter, right? All right, so like that. And I'm doing that one in all caps. It's kind of a comfort thing for me, I guess. I'm putting in a space and then 2 forward slashes. Now, if you read up the documentation on delimiters, they do advise against using any characters for delimiters that are also used inside of regular SQL code. So for example, a backslash is a way to do escape sequences, so you don't want to use that. You also don't want to use a semicolon because you're already using it, that kind of thing. And so they usually use 2 forward slashes or $2 signs or something of that effect. All right, let's put in the create procedure. We can type it, and we'll call it get products, open and close parentheses. And then immediately I put my cursor in between the parentheses and press enter twice. Right. Splits them. And now I can do my parameter list. I'm going to go in 1 tab space. So we're going to have some incoming information here. So we're going to use the in keyword. And we were told what to name it. So I'm just going to follow the name that they gave, which is list price camel cased underscore param. Right. To stand for this is an incoming parameter. This piece is optional. Once again, not a rule, a convention that a lot of programmers use so that when they look at the thing inside their code, they go, oh, that's my parameter. Got it. Right. You can also do it as a prefix. So you can go param underscore list price. Some people just use the letter P. Some will go PRM, whatever. There's no rule, right? It's what works for you. I think param makes it pretty clear. We also need to declare our data type, and we're dealing with money, so we're going to use a decimal, and then we'll allow up to 10, and we will 2 decimal places. So that's the only piece of information that's inbound. All right. Now that we've declared what we're going to name it and our parameters, now we'll put it in the begin command. And then I'm going to hit enter a couple of times. And I'm going to put the end command in right away. Right. And I'm going to close my delimiter and then type in the delimiter, if I can spell it, and then revert it back to a semicolon. Make sure you have a space. Now I'm ready for all my code. I'm going to indent, and now I'm going to try to execute my logic. Now, we were given logic in the document that we need to follow. So here, right, tells us what to select and where it's coming from the products table. But here's the but. With a list price greater than whatever the list price is that we're sending in. So for example, you want to see all the products that are greater than 500 bucks, right? Or $1,000 or $100 or whatever the price is. But notice that there's also this qualification that if they don't send a value in, then we will set that value to 500. And that's actually the piece I'm going to do first, because programmatically that makes the most sense. So I'll start by doing an if statement. So I'm going to use the keyword if, and then I'm going to, once again, I'm going to enter a couple of times, and then I'm going to end my if with a semicolon. So if, end if. A little bit different than Python, a lot different than Java, right? You know, I don't know which languages you guys know. So we'll write our code here, but before we write what code is going to happen, I need to have the situation that I'm going to test for true false right here, right? And what we're testing for is if that list price parameter is empty. If it's null, if that's true, then I will execute the next command, which is I'm going to set the list price parameter equal to 500 because I need some sort of a value to work with. And then I want you to notice here real carefully, there's a semicolon there too. This is really weird how this code works. Really weird. Not at all like Python, where we wouldn't have no semicolons and we wouldn't even have a closing statement. And then in Java, we wouldn't necessarily put that there. We could, but it's optional. So I'd say this is more like Java than it is like Python. All right. Now, all that aside, now we're ready to just do a regular select statement. So what I'm going to do here is they told us what fields to select and from which table. So that's here. I'm just going to drop that in. So we're going to select all of these fields: product ID, product code, product name, list price, and date added from the products table. And now we're going to put in a where and an order by. But here's the why we named this differently, right? Why we added the param to the end of it, because I'm selecting a column from the products table called list price. How confusing would it be, or would it even work, mind you, if I named my parameter internally the same as this? Now notice this has an underscore in the middle. This is camel cased. But with the inclusion of the param piece, it's really clear that they're not the same thing. Some people might omit that, right? And yes, indeed, this is different than that. But when you're looking at your code, like which is which, that's what happens in your head. That's why having the prefix or suffix, whichever approach you take, is really helpful, right? Not a rule, but a convention. Now we're going to do our where clause. So we're going to say where the list price from the products table is greater than the list price parameter that we're sending in. And if we don't send something in, that gets set to 500, right? With the if statement above. Then we'll do simple order by, we're going to order by product name. And then semicolon. So this is the completed file, folks, right? And I'm trying to show you the whole thing here. I'll just zoom out. Let's just do it like that. So that's all of the code right there. All right. I'm going to go ahead and do a Control S to save, right? So, or you can go to File and hit Save, right? Or somewhere up there, there should be a little save icon right there. There's a save icon. You can hit that too. So you can hit that. And now we want to execute this file. We want to execute the whole thing, right? So we're not going to like choose a line and hit the selective run. We're going to hit the first lightning bolt, which runs the whole file. Right. So there it goes. We're assuming it worked. And notice down here, create products, get products, 0 rows affected. How do we know it worked? Well, if we hit the refresh on the schema table, we now see that stored procedures has a get products thing built in, right? So it's ready to run. And mind you, it is not yet compiled into the database. It doesn't compile and become active in memory until I run it. That's kind of a weird little feature. All right, so let's make it run. Let's do that. All right, so in the other file that I created, miscellaneous statements to run, blah, 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 that one, now we're going to put in our command that's going to execute it. And it's very simple. So we're going to experiment with this, by the way. And first thing we do is we call it to run. We call it by name. Notice it found it because it's attached to the database now. And inside those parentheses, I'm going to set a value for which I'm going to look for products that sell for more than that. So I'm going to, last time I used the number 700, I think, and I think we're told to do that, right? So let's call get products and put in the parameter of 700. All right, I'm going to execute that statement. Here it goes. And there's our output, folks. Right. And so are all of these values above 700? Yes, indeed they are. Okay. Let's experiment a little bit. Let's do another run of this, but this time let's not send the value, right? Because that's one of the stipulations. So get products, semicolon, and now I'm going to run this statement. And uh-oh, right? You can tell it's an anticipated uh-oh on my part. It's like error code 1318, incorrect number of arguments for procedure. My guitar shop get product expected 1 got 0, which means you were supposed to send in a parameter and you didn't. Okay, well, I thought I set up my code so that if I don't send in a parameter, it sets it to 500. Okay, but that tells you that I still have to send something in. And if I'm sending nothing in, then I have to use the keyword null. That's the trick. So now I'm going to run it again. And now you see, sure, go ahead, Emma.
I'm getting an error code with the get products 700 even.
All right, we'll have to come back and check your syntax. So okay. I'll tell you what, let me pause the recording here and let's take a look. All right, let's move on to the next exercise. What we did discover, though, is if you need to, let's say you messed up your procedure somehow and it's not running correctly, if you want to remove it, you can use the drop procedure. But when you call the procedure to be dropped, don't put the parentheses after it. It was the trick. All right, moving back to the document here. I'm going to go to the second one here. We're going to modify our procedure and we'll save it as get products count. We'll add an output parameter that will display the product count based on the same criteria, same database. And it says select the count of products into total. The products of those items, the list price greater than. Okay, so we're basically doing the same thing. We're just tweaking this a little bit to modify it to do a couple different little tweaks here. So what we're going to do then, and what makes sense to me, at least from what I'm hearing here, is we're going to follow the same procedure. We're going to keep our input, and then we're just going to tweak our code a little bit. Now, what I suggest that you do is, so we don't have to retype everything, right? And this makes sense to me, is to do a save script as, and then we're going to call this get product count. Get products or product? Products. I'm going to do products. I'm just going to add the word count to it there. And now I have a copy of that, and I'm just going to change the name by adding the word count to it. This parameter is going to stay the same, but we are going to add an output. So we'll do an out command, and this will be a total, and we were told to make it an integer. So this information, when we're done, this will send this information back. Okay. We're still going to have a begin and an end, but we have a different set of criteria here. We don't need the if, right? Well, I mean, you could use the if, right? If you want to, if you want, you can keep that in there, right? Last time I did this, I didn't use it at all, right? And that's not important, but that's what we're doing here. Now we're going to do a select statement, but we're simply going to do a count, right? And we know how to do this. We can just look at the product IDs and count those, and that'll tell us how many products we have, right? I don't need to worry about all those. And then we're going to do into total. So I want to explain what this is doing. The output that we're indicating here is an integer. After it does the count, it will store that value into this variable total. Now, mind you, okay, and this is a little bit weird. You could call this total param if you wish, right? The other thing that you do is when we call this externally, we use a special nomenclature where we put an @ sign in front of it to indicate that it's coming back, right? Just in case we happen to have something else that's called total as well. But I'm just going to leave it like this. All right. So from, all right, so I want to go back to, I got too many documents open here. That's still going to come from the products table. We're still going to have the same criteria, and you can order by the same thing if you wish. All of that is still relevant, right? So the complete stored procedure looks like this. I'm doing Control S to save the SQL file. And now we're going to execute the whole thing. Now I am seeing an error here. And so now I'm trying, the same mistake we saw before. I forgot my comma, right? Because we have a parameter list, so we need a comma there. All right, Control S to save once again. And here comes the run of the whole page, the whole procedure. All right. And I'm not sure if that's the error message from now, or I did get an error message. Okay, so let's see if it updated anything. Okay, it did not update anything. So you have an error in your SQL syntax, check the manual that corresponds to your right syntax and see if it gives me like a line number or something near the comma at line 1. Okay, so now I'm checking my syntax to see what I messed up. And I unfortunately have so many darn windows open. That looks fine. That looks fine. That looks fine. That looks fine. That certainly looks fine. Oh, you know, I'm just thinking about the logic of all this. What are we returning? The count, do we need to order it? Maybe, perhaps not. Um, so one thing I might tweak is I might remove that. I don't think that will change anything. But you know what? Let's just remove that for a second. I'm just trying to humor myself. I think it might be the if statement. Let's run it again. All right, so now it works. So the order by statement was basically irrelevant. And hopefully you guys are good too. And now if I refresh the schema, okay, there it is. Now we're going to go to our other file and we're going to force that to run. And let's use the same syntax. I'm going to copy two statements in here, right? So we're going to run it. And then we're just going to select it. Now I want you to notice here that this is indicating, the @ sign is indicating to us that this is going to generate output that's going to come back to us, right? And then we want to select that. I'm going to run these statements one at a time. Here's the first one. We're good. Now I'm going to run the next one, and now we'll actually see the output. So here it comes, and there it is. So we're just looking at that. But that, you know, designation basically of the @ sign indicates this is the return value. Like I said, if it's helpful for you to indicate that it's a return value and you want to mark it like total underscore return or return underscore total or something like that, that's fine. But the @ sign tells us that this is a variable that's coming back from the procedure. All right, let's move on to the next one. We are kind of gloriously out of time here, aren't we? It is, we have reached, how many more do we have to do? We have a couple more to do. Here's what we're going to do, folks. I am going to cap this here. If you're really eager to get this done, what I will tell you is that the solution I recorded in fall of 2024 has the rest of this in there if you want to go to those. Otherwise, we'll start the next session by finishing our code. So we basically got 1 and 2 done. We still have 3 and 4 to complete. Okay, so this recording ends here, and next week we'll finish it up. The other possibility, and I'm just throwing it out there, I might just record the answer in the aftermath. All right, folks, video's over.